Hey guys, so today I'm going to review with y'all our written exam for Module 4. So let's begin with question 1. For question 1, we are given 4 different shapes: a hexagon, trapezoid, triangle, and a rhombus. We were to write 4 sets of fractions, letting each pattern block be the base unit for a set. The process that I used to solve this problem was to ask how many of each shape fit into the base denominator. For example, letting the hexagon be the base denominator, how many rhombi can fit into a hexagon? So I drew a hexagon, and then I drew a rhombus right here, one right here, and then 2 halves right here, which equals 3. So 3 rhombi can fit into 1 hexagon. How many trapezoids can fit into a hexagon? I drew 1 hexagon, and as you can see, 2 trapezoids can fit into a hexagon, and so on. And for C, it is a little bit confusing because triangles are super small. So using the triangle as a base, for every 1 hexagon, there are 6 triangles. We can fit 6 triangles in a hexagon. So the fraction would be 1/6. For every 1 trapezoid, there are 3 triangles. So it would be 1/3. And for every rhombus, there are 2 triangles. So it would be 1/2. Let's go down to question 2. For question 2, we are supposed to figure out the original length of a rope. If 1/3 is used for a bow painter, 1/4 of that piece is used to tie a carpet, and there are 36 feet left over. So first, we divide the rope into equal parts, and then we divide 36 by 3, which is 12. So 3 parts of the rope are 12 feet long, as you can see right here. And then we split the rest of the rope into 12 feet pieces to find out what the original length is. And so there are 6 pieces of the rope that are 12 feet long. So we would do 6 multiplied by 12, which equals 72. So the original length of the rope is 72 feet long. Let's go to number 3. For question 3, we are to represent the fractions given in parts A through D with fraction strips and number lines. So as you can see, we cut the strips into equal parts for each given fraction. For example, on A, 1/3 is represented by this strip, and 1/2 is represented by this strip, which equals 5/6. This strip is cut into 6 equal parts, and then 5 parts are shaded in. It's kind of like the fraction circle diagram. They're pretty similar. And then you can see that in B also, 1/2 and 3/4 equals 1 and then 1/4. So let's go down to number 4. For number 4, we were to represent the fraction multiplication problems given in A through D with the fraction circle diagram. So first, we have to determine the number of fraction circles to add, and then the fraction circle needed to illustrate the fraction being multiplied. So, for example, in part A, there are 3 identical fraction circles that should be added, and they should all be illustrated with 1/5, as you can see right here, which equals to be 3/5, as you can see right here. And for B, 3 identical fraction circles are to be written as 2/4, which equals 6/4, and then 6/4 equals 1 1/2. And then, as you can see, this is 5/8. We needed 5 identical fraction circles. Oops. Now for number 5, we were given a square that had 7 smaller shapes inside of it named A through G. For each smaller shape, we need to determine what fraction gives the area of each piece. I did this by figuring out how many of each shape can fit into the square. So as you can see, for A, 1/4, it will take 4 of these shapes to fill up the square right here, 4 of these big triangles. And then B, 4 of these will fill up the square as well because they are the same shape as A. And then for C, 16 of these little triangles will fill up the square, so it is 1/16. And D, 8 of these smaller squares will fill up the big square, so it is 1/8. And then E, again, 16 of these smaller triangles will fill up the square, so it is 1/16, and so on. For number 6, we are given a recipe to make 16 brownies. However, we are supposed to figure out how much of each ingredient is needed to make 12 brownies instead of 16. So first, I divided 12 by 16 to get 3/4, and so that means we need 3/4 of the recipe to make 12 brownies instead of 16. Then I multiplied all of the original measurements of the ingredients by 3/4 to see how much of each ingredient we need to make 12 brownies. So for example, 1/3 cups of butter in the original recipe times 3/4 equals 1/4, which means we now need 1/4 cups of butter to make 12 brownies instead of 16. 3 ounces of chocolate times 3/4 equals 2 1/4. 3/4 of a cup of sugar times 3/4 equals 9/16 of a cup of sugar, and so on. Thank you, guys.